Hello, equal 343. So today I'm going to explain labor demand using a calculus example to my friend equal 343. She will be assisting my small session here. Let's get started. So going back to the example of gnomes and unicorns to produce fairy tales, you have to minimize the cost function, which is here, and subject to your production levels. So to do that in calculus, we have to use a Lagrangian method, which is Lagrangian function, and using which is this, and lambda here is the Lagrangian multiplier. We apply the first order conditions to the Lagrangian, and here we have to, go ahead please.
Sorry, why are you equaling it to 0?
Okay, so here you have the first order conditions. We have to, we derive, and then we have to equal to 0, so we're actually minimizing costs. Does that answer your question?
Yes.
Perfect. So we derive in terms of, we derive the Lagrangian in terms of G, and then we derive it in terms of U, and we equate both to 0, and that allows us to find WU and WG in terms of the dy of G and U. And since we already know that we need to maximize this order conditions, we have to equate the marginal product of gnomes over marginal product of unicorns to the marginal rate of transformation of this production function, which is right here. So this is the marginal rate of transformation. This over this is your MRTS, and your WG over your WU is your marginal product factor. Yes, go ahead.
Is that equal to anything in the graph?
Oh, sorry, yes. This factor happens to be the slope of the budget line. And if you draw a graph, your budget line and your production function, when you equate those two at this slope here, this is the optimal point of G and U. So now I'm going to move to actually giving numbers to those digits here. Suppose, let's say, your y is equal to 2g to the power of half, so it's a Cobb-Douglas here, and we have, let's say, your WU is equal to 5, and your y is equal, price of y is equal to 1 in this case. Then we want to maximize profit. So we have this condition here to maximize profits, and the MRTS is, of course, WG over your WU. Okay, so looking at this, your first step needs to be to derive, right? We go back to here and we say, okay, so the derivative of the production function in terms of G would be half, so half, G to the power minus half times U half, and this would be equal to D of Y in terms of the G, and then your dy in terms of du is equal to half, so u to the power minus half times g to the power half, and as we did here, we have to put these in quotient. So this is dy over u, so this over this, vg minus half times u half, which would equal to, let's say, ug over, let's say, u over g. So now we found this condition, which is u over g, which is dyu over dyg, right here, dyu over dyg, and we need to equate that to wg over wu. So your wg over your wu here is u over g is equal to wg over 5 given, which means that your g star is equal to 5 times your u, 5u over g, no sorry, so your g, no let's do this again I think, so your g wg is equal to 5u, which means that your g is equal to 5u over wg. So now we want to find, since we need to find g in terms of y, then we have to find u in terms of y and substitute it into this formula we got here. Doing that, let's make some space here. Okay, perfect. We can find that from the production function, and your your u half is equal to y over 2g half, and your which means that u is equal to y squared over 4g. Putting that back into this function, we get the g star is 5 times u, 5 times u over wg, which finalizes our optimal GNOM level to be 5/4 to the power of half y. So you get that?
Yes.
Y. 5/4 to the power of half y,
Yeah.
over, let's say here, over w to the power half, and your nums. So this is the long run labor demand for G. Thank you.